Hey, I'm Charles McCormick. I was part of the summer 2022 Surf and REU program, the summer at UF, and I am an incoming junior at the University of Southern Mississippi, double majoring in chemistry and polymer science and engineering. And I really look forward to sharing with you all about my research project and experience for this summer. So I was part of the IoT for Ag REU, which is the Internet of Things for Precision Agriculture, and this is an organization funded by the National Science Foundation that specializes in using more integrated technologies such as drones and sensors out in the field, which will allow farmers to more effectively and efficiently manage their crops out in the field on much larger scales. And I actually had the pleasure of like not only being able to contribute to a project using these more advanced technologies, but also being able to see some of these facilities firsthand at an IoT for Ag conference at Purdue University, as well as even be able to see some of the UF's Institute of Food and Agricultural Science facilities. So I was glad to kind of get both the lab experience and also kind of more hands-on, firsthand experiences as well. And another unique aspect I got from being part of this REU is it's multidisciplinary. Like there's people from mechanical engineering, electrical engineering, and computer science and engineering, and then the natural sciences. And I really like there's multiple disciplines working on this on working for this on projects involved in this organization. With that, I'll kind of get into the research I did this summer that focused on trapping toxins in polymer gels. So I worked under the mentorship of Dr. Brent Summerlin out of the chemistry department, and focus of my research was on trapping a specific toxin known as aflatoxin that has been found in peanuts and has even made its way into livestock and milk, and has been found to cause certain diseases in humans such as liver cancer and immune suppression. So one major goal ultimately is to construct an optical sensor that can detect this toxin. So basically the way this would work is we would coat a polymer gel on a gold nanoparticle sensor, and when toxin gets absorbed into the polymer gel, the system would detect a change in refractive index, and so the device would end up reading out a shift in wavelength, and that's what the farmers would use to determine the presence or absence of the toxin. And so my part of the project involved creating the polymer gel coated part of the sensor, and and my project involved using molecular imprinting for making the polymer gel. So this involved first binding a template molecule that's similar to the toxin covalently or non-covalently to a monomer, and then polymerizing in the presence of a crosslinker to form a polymer network all around the template molecules. And once we remove the template, we're able to form these site-specific cavities throughout the polymer network that can re-trap the toxin. And so, um, and so my project this summer has involved creating an optimized polymer gel system that can be used for trapping the toxin and can ultimately be used on this optical sensor. And I was really glad to have been able to contribute to this project. And with that, I'd like to give a special thanks to my faculty mentor, Dr. Brent Summerlin, for giving me the opportunity to work in his lab. And also, I'd like to thank my postdoc mentor, Dr. Emmanuel Shu, for kind of giving me this more full time experience. This was kind of my first time doing a full time research project, and I'd also like to thank the National Science Foundation for funding this project, and also like to thank all other collaborators from other universities who've helped us out on this project. And I'd also like to thank some graduate students have also kind of given us some useful guidance as well. And I was really impressed and really liked the collaboration, being able to meet um, a lot of the grad students in the group. And with that, I'd like to also thank you for taking the time to watch my video.